Now question number 25 is, if a, b, c are distinct odd natural numbers, then number of rational roots of this polynomial ax square plus bx plus c is. Now for rational roots, its discriminant must be a perfect square. So we can write d and we can write this as b square minus 4ac, and it should be equal to some perfect square, say n square. Now this b is odd and 4ac is even, so that means this n, it is an odd number. We can write 4ac as b plus n and b minus n. Now let us say b is some 2k plus 1 and n is some 2l plus 1. Then we can write 4ac and then b plus n will be 2k plus 2l plus 2 and b minus n will be 2k minus 2l. Now here 4 will cancel, then we'll get ac as k plus l plus 1 and then k minus l. Now if we look at this product k plus l minus 1 into k minus l, this product, it will be an even number, because if k minus l is even, then this product will be even. But then a and c, since they are both odd natural numbers, so left hand side is odd and right hand side is even. So that means there cannot be any solution to this equation. If we'll consider this other case when k minus l is odd, then k plus l will also be odd. In that case, k plus l plus 1, they'll be even. So in either case, this right hand side will always be an even number and left hand side will be an odd number. So there cannot be any solution to this equation. So number of rational roots of this polynomial must be 0, and that's your option number A.